We are beginning a new topic today, Binomial Theorem. Here are the objectives that we look forward to achieving at the end of this topic. At the end of this topic, you should know the Pascal's triangle and binomial theorem. And you should be able to use the Pascal's triangle and binomial theorem to expand a binomial expression. As you can see from the objectives of the lesson here, our study on binomial theorem will be mainly focused on the Pascal's triangle, the binomial theorem, and using the Pascal's triangle and binomial theorem to expand a binomial expression. Let's learn more about binomial expressions. In our lesson on algebraic expressions, we learned that a binomial expression is an expression which contains two terms. So for example, if we have a plus b, that is a binomial expression. If let's say we have 2x minus 1, that is a binomial expression. So any expression that contains two terms is a binomial expression. In that lesson, that is the lesson on algebraic expressions, we learned how to expand some binomial expressions. For example, we learned that if you have a plus x squared, it can be expanded as a plus x times a plus x. A times a gives us a squared, a times x gives us ax, x times a is ax, x times x is x squared. When we simplify this, we are going to have a squared plus 2ax plus x squared. Let's say if we have a plus x exponent 3, that gives us a plus x times a plus x times a plus x. We have expanded a plus x squared and we had a plus x times a plus x. When we simplified that, we got a squared plus 2ax plus x squared. So it means that we can replace this a plus x times a plus x here, we can replace it with this. So when we do that, we are going to have a plus x times a squared plus 2ax plus x squared. When we open the bracket here, we are going to have a times a gives us a cube, a times 2as gives us 2a squared x, a times x squared gives us ax squared, x times a squared is a squared x, x times 2ax is 2ax squared, x times x squared gives us s cubed. So this will give us a cubed plus 2a squared x plus 3as cubed plus s cubed. We learned how to do this in the lesson on algebraic expressions. As you can see from the two examples that we have considered here, as the exponent on the binomial expression gets bigger, the expression becomes quite tedious to expand. So for example, in case we want to expand a plus x exponent 4, using this method, it will mean that we have to write a plus x times a plus x times a plus times a plus x again, a plus x times a plus x. Then we will have to multiply them and simplify. That will be quite tedious. It will be better if there is a method that we can use without going through this lengthy process. There is a method like that. It is known as the Pascal's triangle. The Pascal's triangle helps us to get the coefficients of the terms in the binomial expansion. So, for example, if we take the binomial expression a plus x squared, when we expand it, we have a squared plus 2ax plus x squared. The first term here, which is a squared, its coefficient is 1. The second term here, which is 2ax, its coefficient is 2. The third term, which is x squared, its coefficient is 1. The Pascal's triangle helps us to get these coefficients. In the same way, if we take the second example here, which is a plus x exponent 3, we have 4 terms. The first term, its coefficient is 1. The second term, its coefficient is 3. The third term, its coefficient is 3. And the fourth term, the coefficient is 1. The Pascal's triangle helps us to get these coefficients. And once we get these coefficients, the expansion becomes easier. Let's learn more about the Pascal's triangle. Let's say that we have a binomial expression of the form a plus x exponent n, where n is a positive whole number. The Pascal's triangle says that if n is 0, that is, if the exponent on the binomial expression is 0, the binomial expression will have one term and its coefficient will be 1. If n is 1, the binomial expression will have 2 terms. That is, when you expand the binomial expression, its expansion will have 2 terms, and the coefficient of the first term will be 1. The coefficient of the second term will also be 1. If the exponent on the binomial expression is 2, that is, if n is equal to 2, then the expansion will have 3 terms. The coefficient of the first term will be 1. The coefficient of the second term will be 2, and the coefficient of the third term will be 1. If the exponent is 3, that is, if n is 3, then the binomial expansion will have 4 terms. The coefficient of the first term will be 1. The coefficient of the second term will be 3. The coefficient of the third term will be 3. And the coefficient of the last term will be 1. Now you can see that there is a pattern developing here. Let's look at it carefully. So we have 1 here. Here we have 1, 1. Then here we have 1, 2, 1. Now look at this. 1. 1 plus 1 gives us 2. And then we have 1 here. When you come to n is equal to 3, we have 1 here. 1 plus 2 gives us 3. 2 plus 1 gives us 3. And then we have 1 here. Now when n is equal to 4, we have 1 here. 1 plus 3 gives us 4. 3 plus 3 gives us 6. 3 plus 1 gives us 4. And then we end with 1. When n is equal to 5, we have 1 here. 1 plus 4 gives us 5. 4 plus 6 gives us 10. 6 plus 4 gives us 10. 4 plus 1 gives us 5, and then we have 1 here. The order will continue on and on and on. Now what we have here is the coefficients of the binomial expansions. So for example, what this means is that if you have a binomial expansion of the form a plus x exponent n, and n is 4, that is, if the exponent on the binomial expression is 4, then the binomial expression will have 5 terms, and the coefficient of the first term will be 1, the coefficient of the second term will be 4, the coefficient of the third term will be 6, the coefficient of the fourth term will be 4, and the coefficient of the last term will be 1. So if you want to use the Pascal's triangle to expand a binomial expression, the first thing you have to do is to get the coefficients of the expression for that particular exponent. Let's consider an example. Let's say that we want to use the Pascal's triangle to expand the expression a plus x exponent 3. We don't want to multiply a plus x by itself 3 times and then expand like we did in the previous example. Here we want to use the Pascal's triangle to do the expansion. Now if you want to use the Pascal's triangle to do the expansion, the first thing you have to do is to write down the coefficients for this particular exponent. Here the exponent is 3. So we have to write the coefficients for when the exponent is 3. From the triangle that we have considered here, from the Pascal's triangle that we have considered here, when n is 3, that is when the exponent on the binomial expression is 3, the binomial expression will have 4 terms, and the coefficients of the terms will be 1, 3, 3, 1. So we do that here. So for a plus x exponent 3, because the exponent on the binomial expression is 3, the coefficients of the expansion will be 1, 3, 3, 1. Okay. Now, after writing down the coefficients of the expansion, the next thing that you do is that you will take the first term in the binomial expression. Here, the first term in the binomial expression is a. Then you will give the exponent on the expression to a. So here, a will have an exponent of 3. In the next term in the expansion, the exponent of a will reduce by 1. So in the next term, a will have an exponent of 2. In the next term, the exponent on a will reduce by 1 again. So a will have an exponent of 1. And in the last term, the exponent on a will reduce by 1 again. So you have 1 minus 1, and that will be 0. Then after that, you pick the second term in the binomial expression, which is, in this case, we have x. X will have an exponent of 0 in the first term of the expansion. In the next term of the expansion, the exponent on x will increase by 1. So x will have an exponent of 1 because 0 plus 1 is 1. Then in the next term, the exponent on x will increase by 1 again. So 1 plus 1, that gives us 2. Then in the next term, the exponent on x will increase by 1 again from 2 to 3. After that, you add the terms together. So we add the first term to the second term, we add the second term to the third term, and then the third term to the fourth term. Now let's look at something interesting here. When you consider each term, you can see that if you add the exponent of a to the exponent of x, you are going to get 3. So look at this. 3 plus 0 gives us 3. 2 plus 1 gives us 3. 1 plus 2 gives us 3. And 0 plus 3 gives us 3. So when you add the exponents, it's equal to the exponent on the binomial expression. Now let's simplify what we have here. This will give us a cubed plus 3a squared x plus 3ax squared plus x cubed. So you see, using the Pascal's triangle, we have been able to expand this binomial expression without multiplying a plus x by itself 3 times. Let's consider more examples. Use the Pascal's triangle to expand the following. We have 3 questions here. We are going to solve it one after the other. Let's take the first one. We have 1 plus x exponent 4. So the first thing that you do here is that you write the coefficients for when the exponent is 4. So here the exponent on the binomial expression is 4. So you are going to write the coefficients for when the exponent on the binomial expression is 4. When the exponent on the binomial expression is 4, the coefficients will be 1, 4, 6, 4, 1. Okay. Then, after writing the coefficients, you take the first term in the binomial expression and you give the exponent on the expression to it. So here, the first term in the binomial expression is 1. We will give the exponent to it. So in the first term here, 1 will have an exponent of 4. Then in the next term, the exponent on 1 will reduce by 1. So we are going to have 1 exponent 4 minus 1, which will give us 1 exponent 3. In the next term, the exponent, which is 3, will reduce by 1 again. So we have 1 exponent 2. In the next term, the exponent will reduce by 1 again. So 1 exponent 1. In the last term, the exponent will reduce by 1 again. So 1 exponent 0. Then we come to the second term here, which is x. The exponent on x in the first term here will be 0. In the next term, it will increase by 1. So that will be x exponent 1. In the next term, it will increase by 1 again. So that will be x exponent 2. In the next term, it increases by 1 again. So x exponent 3. In the next term, it increases by 1 again. So x exponent 4. Then after that, we add the terms. Now let's simplify. This will give us 1 plus 4x plus 6x squared plus 4x cubed plus x exponent 4. Let's look at the next question. We have p minus q exponent 4. Once again, here the exponent on the expression is 4. So we write the coefficients for when n is 4, or for when the exponent on the expression is 4. And the coefficients will be 1, 4, 6, 4, 1. Then we will take the first term and we will give the exponent 4 to it. So here p will have an exponent of 4. In the next term, it will reduce by 1, so p will have an exponent of 3. The next term reduce by 1 again, so p will have an exponent of 2. In the next term, it will reduce by 1 again, so we have p exponent 1. In the last term, you have p exponent 0. Here, the second term in the expression is negative q. So in the first term here, negative q will have an exponent of 0. In the next term, negative q will have an exponent of 1 because the exponent 0 will increase by 1. So we have negative q exponent 1. In the next term, we have negative q exponent 2. The next term, we have negative q exponent 3. And the last term, we have negative q exponent 4. Then after that, we will add the terms. Now let's simplify. Remember, negative q exponent 0 is 1. So 1 times p exponent 4 times negative q exponent 0 will give us p exponent 4. 4 times p cubed times negative q exponent 1 will give us negative 4p cubed q. 6 times p squared times negative q squared will give us 6p squared q squared, because negative q squared will give us positive q squared. 4 times p exponent 1 times negative 3 cubed will give us negative 4p q cubed. Then in the last term, 1 times p exponent 0, which is 1, times negative q exponent 4, which will give us q exponent 4, will give us q exponent 4. Let's look at the third question. In the third question, we are going to use the Pascal's triangle to expand 2x minus 3 exponent 5. As we have been doing all along, the first thing we have to do here is to write the coefficients for when the exponent on the expression is 5. So here we are writing the coefficients for when n is 5. When the exponent on the expression is 5, the expansion will have 6 terms, and the coefficients will be 1, 5, 10, 10, 5, 1. Okay. So from the Pascal's triangle, we know that when the exponent on the expression is 5, the coefficients will be 1, 5, 10, 10, 5, 1. Okay. Now, we will take the first term. Here, the first term in the expression is 2x. Then we will give the exponent to it. So we have 2x exponent 5. In the next term, the exponent on 2x will reduce by 1. So that will give us 2x exponent 4. In the next term, the exponent on 2x will reduce by 1 again. So that will be 2x exponent 3. In the next term, the exponent on 2x reduces by 1 again. That will give us 2x exponent 2. In the next term, the exponent on 2x reduces by 1 again, so we have 2x exponent 1. And the last term, the exponent on 2x will reduce by 1 again. That gives us 2x exponent 0. Then we take the second term. Here in the expression, we have 2x minus 3 exponent 5. So the second term in the expression is negative 3. So in the first term of the expansion, negative 3 will have an exponent of 0. Then it increases as we move from left to right. It will increase by 1. So in the next one, negative 3 will have an exponent of 1. In the next one, negative 3 will have an exponent of 2. In the next, negative 3 will have an exponent of 3. In the next, negative 3 will have an exponent of 4. And in the next, negative 3 will have an exponent of 5. Then after that, we add the terms together. Now let's simplify. 2x exponent 5 will give us 32x exponent 5. Negative 3 exponent 0 will give us 1. So for the first term, we have 1 times 32x exponent 5 times 1. 2x exponent 4 will give us 16x exponent 4. Negative 3 exponent 1 will give us negative 3. So in the second term, we have 5 times 16x exponent 4 times negative 3. Let's move on to the third term. 2x exponent 3 gives us 8x exponent 3. Negative 3 squared gives us 9. So we are going to have 10 times 8x cubed times 9. 2x squared gives us 4x squared. Negative 3 cubed gives us negative 27. So in the next term, we have 10 times 4x squared times negative 27. Now here, we are going to have 5 times 2x times negative 3 exponent 4 gives us 81. So we have 5 times 2x times 81. And in the last term, 2x exponent 0 gives us 1. Negative 3 exponent 5 gives us negative 243. So we have 1 times negative 243. Let's simplify this. 1 times 32x exponent 5 times 1 gives us 32x exponent 5. 5 times 16x exponent 4 times negative 3 gives us negative 240x exponent 4. 10 times 8x cubed times 9 gives us 270x cubed. 10 times 4x squared times negative 27 gives us 1080x squared. 5 times 2x times 81 gives us 810x. And 1 times negative 243 gives us negative 243. So using the Pascal's triangle, we have been able to expand these binomial expressions. As you can see from the 3 examples that we have considered here, as compared to the previous method that we were using where we multiply the expression by itself. So let's say if you have 1 plus x exponent 4, we write 1 plus x times 1 plus x times 1 plus x times 1 plus x, and then we multiply. When you compare that method to using the Pascal's triangle is relatively easier and faster. But the Pascal's triangle also has its flaw. As you can see from what we have just done here, as the exponent on the expression gets bigger, the Pascal's triangle becomes quite tedious to use. For example, let's say if you are told to expand 2x minus y exponent 7. Using the Pascal's triangle will be quite tedious. So we might need another method that is relatively easier and faster as compared to the Pascal's triangle. There is a method like that, and it is known as the binomial theorem. Let's learn more about the binomial theorem. Binomial theorem. If you have a binomial expression of the form a plus x exponent n, where n is a positive whole number, then using the binomial theorem, we can expand it as n combination 0, a exponent n, x exponent 0 as the first term, plus n combination 1, a exponent n minus 1, x exponent 1 as the second term, plus n combination 0, a exponent n minus 2, x exponent 2 as the third term, and the order continues on and on and on. So this is the binomial theorem. It looks complicated, but it isn't. You can see a pattern clearly developing here. The combinations gives us the coefficients. So if you check the first one, the combination is n combination 0. In the second term, the combination is n combination 1. In the third term, it is n combination 2. So in the fourth term, it's going to be n combination 3. In the fifth term, it's going to be n combination 4. And it continues on and on. Now with the variables, we can see that it's the same as what we were doing when we were using the Pascal's triangle. In the first term, a will have an exponent of n. In the next term, the exponent on a will reduce by 1, so it's going to be n minus 1. In the next term, it will reduce by 1 again, so it's going to be n minus 2. So in the next term, it reduces by 1 again, so that's n minus 3. Now, when we look at x, which is the second term in the expression, its exponent in the first term of the expansion will be 0, just as it was when we were using the Pascal's triangle. Then in the next term, it will increase by 1. So that will be x exponent 1. Then in the next term, it increases by 1 again. So that will be x exponent 2. Then in the next term, it increases by 1 again. So x exponent 3. And then it keeps on and on and on. So you don't necessarily have to memorize anything here. Just follow the pattern and you'll be able to generate the binomial theorem. Now, how do we find the combinations? So let's say n is 5. Let's assume n is 5 and you want to find, let's say, 5 combination 3. How do you do that? You can easily do that on your calculator. So I'm going to show you how to do that on the calculator. I have my calculator here. So to find, let's say, 5 combination 3, what you have to do is that you press on 5, then you press shift, then the division sign, that will give you combination, then you press on 3. So you see on the calculator, we now have 5 combination 3. Then you press equal to. So 5 combination 3 gives us 10. Let's try another one. Let's say we want to find 4 combination 2. So you press 4, then you press on shift, then combination, the division sign. So you press shift and the division sign, that gives you combination. Then you press 2. So that gives us 4 combination 2. Then you hit equal to, and that gives us 6. So 4 combination 2 is 6. Let's try one more. Let's say we want to find 6 combination 5. Or let's say 6 combination 1. Okay, let's 6 combination 1. So you press 6, then shift, then the division sign, and then 1. So that gives us 6 combination 1. Then you hit equal to, and that gives you the answer. So here 6 combination 1 is 6. So this is how to find the combinations that you have in the binomial theorem. Now let's go ahead and use the binomial theorem to solve some questions. We are going to use it to expand some binomial expressions. So let's say we want to use the binomial theorem to expand a plus x exponent 3. From the binomial theorem, if we want the expansion of a plus x exponent 3, the first term is going to be 3 combination 0, a exponent 3, x exponent 0. So you see, if you compare to the theorem, we have n combination 0, where n is the exponent on the expression. Here, the exponent on the expression is 3. So we are going to have 3 combination 0. Then a will have exponent 3, because here we have a exponent n. So a will have exponent 3. Then x will have an exponent of 0. Now, let's look at the next term. The next term, we are going to have 3 combination 1, a exponent 2, x exponent 1. So the combination is going to be 3 combination 1, just as you have here n combination 1. And n is 3, so 3 combination 1. Now the exponent on a will reduce by 1, just as we were doing when we were using the Pascal's triangle. So a exponent 3 will now become a exponent 2. Then the exponent on x will increase by 1. So x exponent 0 will become x exponent 1. Now the next term, which is the third term, will be 3 combination 2. The exponent on a will reduce by 1. So we are going to have a exponent 1. The exponent on x will increase by 1. So x exponent 2. Then the fourth term, which is the last term, will be 3 combination 3. Then the exponent on a will reduce by 1, so a exponent 0. And the exponent on x will increase by 1, so x exponent 3. We can find 3 combination 1 on the calculator. When you find 3 combination 1 on the calculator, you are going to have 1. A exponent 3 gives us a exponent 3. Then x exponent 0 gives us 1. 3 combination 1 is 3. A squared. X exponent 1 is x. 3 combination 2 is also 3. A exponent 1 times x squared. 3 combination 3 is 1. Then a exponent 0 is 1. And x exponent 3 gives us 3. So as you can see, the combinations gives us the coefficients. The coefficients that the Pascal's triangle was giving to us. That is what the combinations gives us here. When we simplify this, you're going to have a exponent 3 plus 3a squared x plus 3ax squared plus x exponent 3. Let's use the binomial theorem to solve some more questions. Write down the binomial expansion of x minus 2y exponent 5. So here we are going to use the binomial theorem. You can also use the Pascal's triangle in this question because the question did not specify, but we want to use the binomial theorem here. So we know that from the binomial theorem, if we have a plus x exponent n, this would be the expansion. Here we have x minus 2y exponent 5. So it means that n is 5. The exponent on the expression is 5. So for the first term, you are going to have 5 combination 0. Then the first term in the expression, which is x, will have an exponent of 5. The second term in the expression, which is negative 2y, will have an exponent of 0. Then in the next term, we will have 5 combination 1. Here, the exponent on x is 5. So in the next term, the exponent on x will reduce by 1. We reduce 5 by 1 and that will be 4. So we have x exponent 4. Then the exponent on negative 2y, which is 0, will increase by 1. So we have negative 2y exponent 1. We go on to the next term. For the next term, we have 5 combination 2. So you look at the combinations. 5 combination 0. The next term becomes 5 combination 1. The next term, it becomes 5 combination 2. Now for the variables, x exponent 4, the exponent 4 reduced by 1 to x exponent 3. Negative 2y exponent 1, the 1 will increase by 1 to negative 2y squared. Then the next term, the combination will be 5 combination 3. We had 5 combination 2 here, so the next one will be 5 combination 3. The exponent on x will reduce by 1, so we move from x exponent 3 to x squared. Then the exponent on negative 2y will increase by 1, so we move from negative 2y squared to negative 2y cubed. Then the next term, we have 5 combination 4. the exponent on x will reduce by 1. So we are going to have x exponent 1. The exponent on negative 2y will increase by 1. So negative 2y exponent 4. Then the last term will be 5 combination 5. So you see we start from 5 combination 0 and then we end at 5 combination 5. That will be the last term. The exponent on x will reduce by 1. So 1 minus 1 is 0, and so we have x exponent 0. Then the exponent on negative 2y will increase by 1. 4 plus 1 is 5, so we have negative 2y exponent 5. So you see, if you get used to the pattern, you don't necessarily have to memorize the binomial theorem. Now let's simplify this. 5 combination 0 is 1. X exponent 5 is x exponent 5. Negative 2y exponent 0 is 1. For the next term, 5 combination 1 is 5. X exponent 4 is x exponent 4. Negative 2y exponent 1 is negative 2y. Then the third term, 5 combination 2 is 10. X exponent 3 gives us x cubed. Negative 2y squared gives us 4y squared. The fourth term, 5 combination 3 is 10. X squared is x squared. Negative 2y exponent 3 is negative 8y exponent 3. For the next term, 5 combination 4 gives us 5. X exponent 1 is x. Negative 2y exponent 4 is 16y exponent 4. Then for the last term, 5 combination 5 gives us 1. X exponent 0 gives us 1. Negative 2y exponent 5 gives us negative 32y exponent 5. So as you can clearly see, the combinations gives us the coefficients that the Pascal's triangle was given to us. So you look at it. You have 1, 5, 10, 10, 5, 1. Let's simplify this. 1 times x exponent 5 times 1 gives us x exponent 5. 5 times x exponent 4 times negative 2y gives us negative 10 x exponent 4y. 4 times x cubed times 4y squared gives us 40 x cubed y squared. 10 times x squared times negative 8y cubed gives us negative 80 x squared y cubed. 5 times x times 16y exponent 4 gives us 80xy exponent 4. And 1 times negative 32y exponent 5 gives us negative 32y exponent 5. So using the binomial theorem, we have been able to expand this binomial expression. Let's look at the next question. Write down the binomial expansion of 1 plus x exponent 4 and use the result in I to evaluate 5 divided by 4 exponent 4, correct to 3 decimal places. So let's look at the first part of the question. We are going to write down the expansion of 1 plus x exponent 4. We are going to use the binomial theorem here. This is the binomial theorem in case you want to refer to it. So using the binomial theorem, the first term of the expansion will be 4 combination 0, then 1 exponent 4, x exponent 0. The next term will be 4 combination 1, 1 exponent 3, x exponent 1. So you move from 4 combination 0 to 4 combination 1. The exponent on 1 will reduce by 1 to 3, and the exponent on x will increase from 0 to 1. The next term will be 4 combination 2, 1 squared, x squared. We move from 4 combination 1 to 4 combination 2. The exponent on 1 will reduce by 1, so 1 exponent 3 becomes 1 squared. Then the exponent on x will increase by 1, so x exponent 1 becomes x squared. The next one, we have 4 combination 3, 1 exponent 1, x exponent 3. So we move from 4 combination 2 to 4 combination 3. 1 squared becomes 1 exponent 1 because the 2 reduced by 1. Then x squared becomes x cubed because the 2 increased by 1. Then for the last term, 4 combination 4, the exponent on 1 will reduce by 1, so that will be 1 exponent 0. Then the exponent on x will increase by 1, so x exponent 4. Now let's simplify. 4 combination 0 is 1. 1 exponent 4 is 1. X exponent 0 is also 1. The next term, 4 combination 1 is 4. 1 exponent 3 is 1. X exponent 1 is x. For the next term, 4 combination 2 is 6. 1 exponent 2 is 1. X squared is x squared. Then for the next term, 4 combination 3 is 4. 1 exponent 1 is 1. X exponent 3 is x exponent 3. Then for the last term, 4 combination 4 is 1. 1 exponent 0 is 1. And x exponent 4 is x exponent 4. When you simplify this, we are going to have 1 plus 4x plus 6x squared plus 4x cubed plus x exponent 4. Now let's look at the second part of the question. The second part of the question says that we should use the result that we got in I, which is the expansion of the binomial expression, to evaluate 5 divided by 4 exponent 4. And we should correct our answer to 3 decimal places. When we expanded the binomial expression 1 plus x exponent 4, we had 1 plus 4x plus 6x squared plus 4x cubed plus x exponent 4. So we are going to use this expansion to evaluate 5 divided by 4 exponent 4. When you have a question like this, you have to write the expression. That is the expression you want to evaluate. So in this case, 5 divided by 4 exponent 4. You have to write it in the same form as the binomial expression. So here we are going to write 5 divided by 4 exponent 4 in the same form as 1 plus x exponent 4. Now 5 divided by 4 will give us 1.25. So when you write 5 divided by 4 in decimals, we are going to have 1.25. So 5 divided by 4 exponent 4 will be equal to 1.25 exponent 4. So what we have to do here is that we have to write 1.25 exponent 4 in the same form as 1 plus x exponent 4. Now the easiest way to do that is to compare them. So we are going to compare 1 plus x exponent 4 to 1.25 exponent 4. Now when you compare them, you can see that we have exponent 4 here, we have exponent 4 here. So then we can equate 1 plus x to 1.25. When you equate 1 plus x to 1.25, you can solve for x here. So x will be equal to 1.25 minus 1. And so x will be equal to 0.25. This means that 1.25 exponent 4 can be written as 1 plus 0.25 exponent 4. Now you can see that now we have 1.25 exponent 4 in the same form as 1 plus x exponent 4. As we have seen, 5 divided by 4 exponent 4 will be equal to 1.25 exponent 4, which is 1 plus 0.25 exponent 4. And so by comparison, we can see that x is 0.25. So if you want the value of 5 divided by 4 exponent 4, we have to substitute x is equal to 0.25 into this expansion. So when we do that, we are going to have 1 plus 4 times 0.25 plus 6 times 0.25 squared plus 4 times 0.25 cubed plus 0.25 exponent 4. When we simplify this and correct our answer to 3 decimal places, just as the question says we should, we are going to have 2.441. So this means that 5 divided by 4 exponent 4 is 2.441. Let's consider the next question. Write down the binomial expansion of 1 plus 3x exponent 5. Use your expansion in I to evaluate 1.03 exponent 5, correct to 4 decimal places. Let's look at the first part of the question. We are going to write down the binomial expansion of 1 plus 3x exponent 5. Once again, you can use the Pascal's triangle here if you prefer the Pascal's triangle, because the question did not tell us to use the binomial theorem to expand it. So you can either use the Pascal's triangle or the binomial theorem. In this example here, I'm going to use the binomial theorem. So we are going to write down the expansion of 1 plus 3x exponent 5. This is the binomial theorem in case you want to refer to it. The first term is going to be 5 combination 0. Then the first term in the expression, which is 1, will have the exponent 5. Then the second term, which is 3x, will have the exponent 0. In the next term, the 5 combination 0 becomes 5 combination 1. The exponent on 1, which is 5, will reduce by 1 to 4. The exponent on 3x, which is 0, will increase by 1 to 1. Then the next term, 5 combination 1, will now become 5 combination 2. The exponent on 1, which is 4, will reduce by 1 to 3. The exponent on 3x, which is 1, will increase by 1 to 2. The next term, we have 5 combination 3. The exponent on 1 will reduce by 1 to 2. And the exponent on 3x will increase by 1 to 3. The next term will be 5 combination 4. The exponent on 1, which is 2, will reduce by 1 to 1. And the exponent on 3x, which is 3, will increase by 1 to 4. Then in the next term, we are going to have 5 combination 5. The exponent on 1 will reduce by 1 to 0. And the exponent on 3x will increase by 1 to 5. Now let's simplify this. 5 combination 0 is 1, 1 exponent 5 is 1, 3x exponent 0 is 1. 5 combination 1 is 5, 1 exponent 4 is 1, 3x exponent 1 is 3x. 5 combination 2 is 10, 1 exponent 3 is 1, 3x squared gives us 9x squared. 5 combination 3 is 10, 1 exponent 2 is 1, 3x exponent 3 is 27x cubed. 5 combination 4 is 5, 1 exponent 1 is 1, 3x exponent 4 is 81x exponent 4. 5 combination 5 is 1, 1 exponent 0 is 1, then 3x exponent 5 gives us 243x exponent 5. When you simplify this, you are going to have 1 times 1 times 1 is 1. 5 times 1 times 3x gives us 15x. 10 times 1 times 9x squared gives us 90x squared. 10 times 1 times 27s cubed gives us 270s cubed. 5 times 1 times 81x exponent 4 gives us 405x exponent 4. Then 1 times 243x exponent 5 gives us 243x exponent 5. The second part of the question says that we should use the expansion that we had in I, which is this, to evaluate 1.03 exponent 5 and correct our answer to 4 decimal places. Just as I explained to you in the previous example, if you are asked to evaluate something like this, you have to compare the expression that you are given to the binomial expression. So here we are going to compare 1.03 exponent 5 to 1 plus 3x exponent 5 for the value of x. Then we will substitute that value of x into this expansion. So we are going to compare 1.03 exponent 5 to 1.3x exponent 5. And by comparison, you can see we have 5 here, 5 here. The exponents are the same from indices. If the exponents are the same, then it means we can equate the bases. So we equate 1 plus 3x to 1.03. Then from here we can find the value of x. So we are going to have 3x is equal to 1.03 minus 1. This gives us 3x is equal to 1.03 minus 1 gives us 0.03. To get the value of x, we will divide both sides by 3, and that will give us 0.03 divided by 3. And so x will be equal to 0.01. So what this means is that if we want to use this expansion to evaluate 1.03 exponent 5, then we will have to substitute x is equal to 0.01 into this expansion. We have x is equal to 0.01. This means that 1.03 exponent 5 is equal to 1 plus 3 into brackets 0.01 exponent 5. So if we want to use this expansion to evaluate 1.03 exponent 5, then we have to substitute x is equal to 0.01 into this expansion. When we do that, we are going to have 1 plus 15 into bracket 0.01 plus 90 into bracket 0.01 squared plus 270 into bracket 0.01 cube plus 405 times 0.01 exponent 4 plus 243 times 0.01 exponent 5. When you evaluate this and you correct your answer to 4 decimal places, you are going to have 1.1593. So using the expansion of 1 plus 3x exponent 5, 1.03 exponent 5 corrected to 4 decimal places will be 1.1593. Let's look at the next question. Expand x minus 1 exponent 12 in ascending powers of x up to the 5th term. So here we are going to write the expansion up to the 5th term. We will not go beyond that. Now let's consider something. We know that from the binomial theorem, if we have a plus x exponent n, we can expand it as n combination 0, a exponent n, x exponent 0, plus n combination 1, a exponent n minus 1, x exponent 1, plus n combination 2, a exponent n minus 2, x exponent 2, then the order continues. I want you to pay attention here. Let's look at the exponents on a and x. Let's first consider a. So for a, in the first term, the exponent is n. In the next term, the exponent is n minus 1. In the next term, the exponent is n minus 2. How about x? For the first term, the exponent on x is 0. For the second term, the exponent on x is 1. For the third term, the exponent on x is 2. So if the order continues, it means that for the fourth term, the exponent on x will be 3. So as you can clearly see, the exponent on x, or the powers of x, as we move from left to right, it increases. It is in ascending order. What this means is that when we are using the binomial theorem, the first term in the binomial expression, its exponent will decrease as we move from left to right. And the second term in the binomial expression, its exponent will increase, or its exponent will ascend as we move from left to right. So it means that here, if we want to write the expansion of this binomial expression in ascending powers of x, then the term containing x should be the second term in the binomial expression, because in the binomial theorem, the first term in the binomial expression will be in descending powers, and we don't want that. We want ascending powers of x. And so because we want ascending powers of x, then it means that x should be the second term in the binomial expression. And we can easily do that because we know from algebra that x minus 1 exponent 12 can also be written as -1 plus x exponent 12. So now x has become the second term in the binomial expression. And so when we use the binomial theorem to expand this expression, we are going to have it in ascending powers of x. Okay, so now let's write the expression. So here we are going to expand -1 plus x exponent 12, which is also the same as x minus 1 exponent 12. But because we want the expansion in ascending powers of x, that is why we wrote the x as the second term. So using the binomial theorem, the first term is going to be 12 combination 0. Then -1 will have an exponent of 12, and x will have an exponent of 0. Remember that we are expanding up to the fifth term, so we will not go beyond the fifth term. The second term is going to be the 12 combination 0 becomes 12 combination 1. The exponent on -1 will reduce by 1, so 12 will reduce by 1 to 11. Then x will increase from 0 to 1. So you see, we are now having ascending powers of x. The powers of x is increasing, which is what we want. If we had kept it as x minus 1 exponent 12, then the powers of x will decrease. We don't want that. We want the powers of x to increase. That is why we interchanged them. Let's move on to the third term. So in the third term, 12 combination 1 will become 12 combination 2. The exponent on -1, which is 11, will reduce by 1 to 10. And the exponent on x, which is 1, will increase by 1 to 2. That will be for the third term. For the fourth term, we have 12 combination 3. The exponent on -1, which is 10, will reduce by 1 to 9. The exponent on x, which is 2, will increase by 1 to 3. This is the fourth term. Now for the fifth term, we are going to have 12 combination 4. Then the exponent on -1 will reduce by 1 to 8. It's 9 here, so it will reduce by 1 to 8. Then the exponent on x will increase by 1 to 4. It's 3 here, so when we increase it by 1, we are going to get to 4. Remember, we are expanding up to the fifth term, and this is the fifth term. But there are other terms that follows this, so we have to bring the addition sign and the 3 dots to show that there are other terms that follows this. But we are only ending at the fifth term because the question says we should end at the fifth term. Now let's simplify this. 12 combination 0 is 1. -1 exponent 12 is 1. X exponent 0 is 1. For the second term, 12 combination 1 is 12. -1 exponent 11 is -1. X exponent 1 is x. For the third term, 12 combination 2 is 66. negative 1 exponent 10 is 1. X exponent 2 is x squared. For the fourth term, 12 combination 3 is 220. Negative 1 exponent 9 is negative 1. X exponent 3 is s cubed. And for the fifth term, 12 combination 4 is 495. Negative 1 exponent 8 is 1. X exponent 4 is x exponent 4. When we simplify this, we are going to have 1 times 1 times 1, which is 1. 12 times negative 1 times x gives us negative 12x. 66 times 1 times x squared gives us 66x squared. 220 times negative 1 times s cubed gives us negative 220s cubed. And 495 times 1 times x exponent 4 gives us 495 x exponent 4. And we bring the addition sign and the 3 dot to show that there are other terms that follows. But we are only ending at the fifth term because the question says that we should end at the fifth term. Now when you look at the expansion here, you can see that x is in ascending powers. So in the first term, we have x exponent 0, which is 1. That is why the x is not there. In the second term, we have x exponent 1, which is the same as x. In the third term, we have x exponent 2. In the fourth term, we have x exponent 3. In the fifth term, we have x exponent 4. So the powers of x is ascending. Remember that if the question does not tell you to write x in ascending or descending powers, you can just leave it the same way as the question was given to you and you continue with your expansion. You only have to interchange the positions when you want the x to be in either ascending powers or descending powers. So the position of x will be based on whether you want it to be in ascending powers or descending powers. Let's look at the next example. So in this example, it says that we should expand 1 plus 2x exponent 4 in descending powers of x. So in this case, we have to write x in descending powers. That is from the highest to the lowest. Then for the second part of the question, it says that use your expansion in I to evaluate 1.05 exponent 4. We should correct our answer to 4 significant figures. So let's look at the first part of the question. It says that we should expand 1 plus 2x exponent 4 in descending powers of x. Now, in the previous example that we solved, we realized that if we want x in ascending powers, then we will have to write x as the second term of the expression. Here, we want x in descending powers. From the binomial theorem, we realize that the first term will always be in descending powers, and the second term will be in ascending powers. So here, if we want x to be in descending powers, then it means that x should be the first term. So the term containing x should be the first term if we want it to be in descending powers. And so we are going to rewrite 1 plus 2x exponent 4 as 2x plus 1 exponent 4. Then we will expand this, because when we expand this, we will have x in descending powers. We know that 1 plus 2x is the same as 2x plus 1, so we've not really changed anything here. 1 plus 2x exponent 4 is equal to 2x plus 1 exponent 4. We are only changing the positions of 2x and 1 because we want x to be in descending powers. Okay, so we are going to expand 2x plus 1 exponent 4. Using the binomial theorem, the expansion of 2x plus 1 exponent 4 will be equal to 4 combination 0, 2x exponent 4, then 1 exponent 0. This will be the first term. For the second term, you are going to have 4 combination 1. The exponent on 2x, which is 4, will reduce by 1 to 3. The exponent on 1, which is 0, will increase to 1. So we have 4 combination 1, 2x exponent 3, then x exponent 1. The next term, you are going to have 4 combination 2, 2x squared, 1 squared. Then the next one will be 4 combination 3, 2x exponent 1, 1 cube. Then the last term will be 4 combination 4, 2x exponent 0, 1 exponent 4. 4 combination 0 is 1, 2x exponent 4 is 16x exponent 4, 1 exponent 0 is 1, 4 combination 1 is 4, 2x cube is 8x cube, 1 exponent 1 is 1, 4 combination 2 is 6, 2x squared is 4x squared, 1 squared is 1, 4 combination 3 is 4, 2x exponent 1 is 2x, 1 exponent 3 is 1, 4 combination 4 is 1, 2x exponent 0 is 1, and then x exponent 4 is also 1. When we simplify this, we are going to have 1 times 16x exponent 4 times 1 is 16x exponent 4, 4 times 8x cubed times 1 is 32x cubed, 6 times 4x squared times 1 is 24x squared, 4 times 2x times 1 is 8x, then 1 times 1 times 1 is 1. So as you can see here, we have x in descending powers. In the first term, x has an exponent of 4. In the second term, x has an exponent of 3. In the third term, x has an exponent of 2. In the fourth term, x has an exponent of 1. And in the last term, x has an exponent of 0. So x is in descending powers. Once again, if the question does not tell you to write the expansion in ascending or descending powers of a particular variable, you don't have to interchange the positions of the terms in the expansion. Here, if the question had just said expand 1 plus 2x exponent 4, we would have kept it as 1 plus 2x exponent 4. We only switched the positions of the term because we wanted x in descending powers. Okay. Now let's look at the second part of the question. It says that we should use our expansion to evaluate 1.05 exponent 4 and correct our answer to 4 significant figures. So here, just as we have been doing all along, we will have to compare 1.05 exponent 4 to 2x plus 1 exponent 4. So we are comparing 1.05 exponent 4 to 2x plus 1 exponent 4. By comparison, we can see that the exponents are the same, so we can equate the bases. And so 2x plus 1 will be equal to 1.05. We are going to solve for x here, so 2x will be 1.05 minus 1. This gives us 2x is equal to 0.05. Then to get x, we will divide both sides by 2. So we are going to have 0.05 divided by 2, and so x will be equal to 0.025. So it means that if we want to use our expansion to evaluate 1.05 exponent 4, we will have to substitute x is equal to 0.025 into the expansion. So from what we have done here, we can see that 2x plus 1 exponent 4 will be equal to 2 times 0.025 plus 1 exponent 4. So by comparison, x will be 0.025. And so if we want the value of 1.025 exponent 4, we will have to substitute 0.025 into this expansion. Let's do that. Okay, so when we do that, we are going to have 16 times 0.025 exponent 4 plus 32 times 0.025 exponent 3 plus 24 times 0.025 exponent 2 plus 8 times 0.025 plus 1. When we evaluate this and correct the answer to 4 significant figures, we are going to have 1.216. So what it means is that 1.05 exponent 4 is equal to 1.216. Let's consider the next question. Expand x plus y exponent 4. Use your expansion to find, correct to 2 decimal places, the value of 2.02 exponent 4. Our question is in two parts. For the first part, we are going to expand x plus y exponent 4. And for the second part, we will use the expansion to evaluate 2.02 exponent 4. And then we will correct our answer to 2 decimal places. So let's start with the first part. We are going to expand x plus y exponent 4. We have learnt that if you have a binomial expression of the form a plus x exponent n, it can be expanded as n combination 0 a exponent n x exponent 0 plus n combination 1 a exponent n minus 1 x exponent 1 n combination 2 a exponent n minus 2 x exponent 2, and the order continues on and on. When we compare the binomial expression we have here to a plus x exponent n, we can see that a, which is the first term, will be x, then x, which is the second term, will be y, and then n, which is the exponent on the binomial expression, is 4. So n is 4. So for the expansion, the first term is going to be 4 combination 0, x exponent 4, y exponent 0. Then for the second term, we are going to have 4 combination 1. The exponent on x, which is 4, reduces by 1 to 3, and the exponent on y, which is 0, increases by 1. For the third term, we are going to have 4 combination 2, x squared, y squared. For the fourth term, we are going to have 4 combination 3, x exponent 1, y exponent 3. And for the last term, we are going to have 4 combination 4, x exponent 0, y exponent 4. Let's simplify this. 4 combination 0 is 1, x exponent 4 is x exponent 4, y exponent 0 is 1. 4 combination 1 is 4, x exponent 3 gives us x cubed, y exponent 1 gives us y. 4 combination 2 is 6, we have x squared, y squared. 4 combination 3 is 4, x exponent 1 is x, y exponent 3 is y cubed. And 4 combination 4 is 1, x exponent 0 is 1, and y exponent 4 gives us y exponent 4. 1 times x exponent 4 times 1 gives us x exponent 4. 4 times x cubed y gives us 4x cubed y. 6 times x squared y squared gives us 6x squared y squared. 4 times x times y exponent 3 gives us 4x y exponent 3. 1 times 1 times y exponent 4 gives us y exponent 4. So this is the expansion of x plus y exponent 4. Let's consider the second part of the question. The second part of the question says that we should use the expansion to evaluate 2.02 exponent 4. Now this is the expansion. X plus y exponent 4 gives us x exponent 4 plus 4x cubed y plus 6x squared y squared plus 4x y cubed plus y exponent 4. So here, if we are going to use this expansion to evaluate 2.02 exponent 4, then we will have to express 2.02 exponent 4 such that it looks like x plus y exponent 4. And we can do that by comparing. So we are going to compare x plus y exponent 4 to 2.02 exponent 4. And by comparison, we can see that we have exponent 4 here, exponent 4 here, so we can equate the bases. So x plus y is equal to 2.02. If I make y the subject here, I'm going to have y is equal to 2.02 minus x. Now here, you have to assume a value for x, then you substitute it into this equation to get a corresponding value for y. You can assume any value for x except 0, because if x is 0, then the expression x plus y becomes 0 plus y, and 0 plus y gives us y, which is not a binomial expression. We want a binomial expression, so you can't assume x to be 0. X can be any value except 0, but I would advise that you choose smaller values for x so that your calculation does not get complicated. So here I'm going to choose x is equal to 1. So if I choose x is equal to 1, I'll substitute it into this equation to get y. When I do that, I'm going to have y is equal to 2.02 minus 1. And that gives us y is equal to 1.02. So what it means is that if I want to use the expansion of x plus y exponent 4 to evaluate 2.02 exponent 4, then I'll have to substitute x is equal to 1 and y is equal to 1.02 into this expansion. So I can write 2.02 exponent 4 as 1 plus 1.02 exponent 4. So if I'm going to use the expansion of x plus y exponent 4 to evaluate 2.02 exponent 4, then I will substitute x is equal to 1 and y is equal to 1.02 into this expansion. Let's do that. So we are going to have 1 plus 1.02 exponent 4, which is the same as 2.02 exponent 4, to be equal to, we will substitute x is equal to 1 and y is equal to 1.02 into this expansion. So where we see x, we will replace it with 1, and where we see y, we will replace it with 1.02. So that gives us 1 exponent 4 plus 4 times 1 cubed times 1.02 plus 6 times 1 squared times 1.02 squared plus 4 times 1 times 1.02 cubed plus 1.02 exponent 4. Now this gives us 1 plus 4.08 plus 6.2424 plus 4.244832 plus 1.0824321. When you add all of this and you correct the answer to 2 decimal places, you are going to have 16.65. So what this means is that when we use the expansion of x plus y exponent 4 to evaluate 2.02 exponent 4 and we correct our answer to 2 decimal places, we are going to have 16.65. Let's consider the next question. Write down the binomial expansion of x plus 2y exponent 5. Use your expansion in I to evaluate 1.02 exponent 5. Correct to 3 decimal places. So we will first expand x plus 2y exponent 5. Then we will use the expansion to evaluate 1.02 exponent 5. And then we will correct the answer to 3 decimal places. Let's begin with the first one, the expansion of x plus 2y exponent 5. We have learned that if you have the binomial expression a plus x exponent n, it can be expanded as this. So we are going to use this binomial expansion to expand x plus 2y exponent 5. So for the first term, you are going to have 5 combination 0. X, which is the first term, will have an exponent of 5. 2y, which is the second term, will have an exponent of 0. Then in the second term, 5 combination 0 becomes 5 combination 1. The exponent on x reduces from 5 to 4, and the exponent on 2y increases from 0 to 1. Then in the next term, you have 5 combination 2. The exponent on x reduces from 4 to 3. The exponent on 2y increases from 1 to 2. In the next term, we have 5 combination 3. The exponent on x reduces from 3 to 2. The exponent on 2y increases from 2 to 3. In the next term, we have 5 combination 0. The exponent on x reduces from 2 to 1. The exponent on 2y increases from 3 to 4. Then the last term, we have 5 combination 5. The exponent on x reduces from 1 to 0. The exponent on 2y increases from 4 to 5. Let's simplify this. 5 combination 0 is 1. X exponent 5 is x exponent 5. 2y exponent 0 is 1. 5 combination 1 is 5. X exponent 4 is x exponent 4. 2y exponent 1 is 2y. 5 combination 2 is 10. X exponent 3 is x exponent 3. 2y squared gives us 4y squared. 5 combination 3 is 10. X squared gives us x squared. 2y cubed gives us 8y cubed. 5 combination 4 is 5. X exponent 1 gives us x. 2y exponent 4 gives us 16y exponent 4. 5 combination 5 is 1. X exponent 0 is 1. Then 2y exponent 5 is 32y exponent 5. Let's simplify this. 1 times x exponent 5 times 1 gives us x exponent 5. 5 times x exponent 4 times 2y gives us 10x exponent 4y. 10 times x cubed times 4y squared gives us 40x cubed y squared. 10 times x squared times 8y cubed gives us 80x squared y cubed. 5 times x times 16y exponent 4 gives us 80xy exponent 4. And lastly, 1 times 32y exponent 5 gives us 32y exponent 5. So this is the expansion of x plus 2y exponent 5. Let's consider the second part of the question. The second part of the question says that we should use the expansion that we just had to evaluate 1.02 exponent 5 and correct our answer to 3 decimal places. So to do that, we are going to compare 1.02 exponent 5 to x plus 2y exponent 5. Now, when we compare, we can see that we have exponent 5 here, we have exponent 5 here, so we can equate the bases. So we can say that x plus 2y is equal to 1.02. Here, I'm going to make y the subject, so I'm going to write 2y is equal to 1.02 minus x. Now, just as we did in the previous example, here too, I'm going to assume a value for x. I'll substitute it into the equation. Then I'll get a corresponding value for y, so that I can substitute those x and y values into the expansion to get the value of 1.02 exponent 5. Like I said in the previous example, you can choose any value for x except 0. But I would advise that you choose smaller values for x so that your calculations do not become complicated. So here I'm going to choose x is equal to 1. When I choose x is equal to 1, then the equation becomes 2y is equal to 1.02 minus 1. 1.02 minus 1 gives us 0.02. So 2y is equal to 0.02. To get y, we divide both sides by 2, and so y will be equal to 0.01. So what this means is that if we are going to use this expansion to evaluate 1.02 exponent 5, I'm going to substitute x is equal to 1 and y is equal to 0.01 into the expansion. So 1.02 exponent 5 can be written as 1 plus 2 times 0.01 exponent 5. So by comparison, you can see that x is 1 and y is 0.01. So we will substitute x is equal to 1 and y is equal to 0.01 into this expansion. Let's do that. I'm going to have 1 exponent 5 plus 10 times 1 exponent 4 times 0.01 plus 40 times 1 cube times 0.01 squared plus 80 times 1 squared times 0.01 cubed plus 80 times 1 times 0.01 exponent 4 plus 32 times 0.01 exponent 5. When you simplify this and correct the answer to 3 decimal places, you are going to have 1.104. So this means that if we use the expansion of x plus 2y exponent 5 to evaluate 1.02 exponent 5 and correct our answer to 3 decimal places, we are going to have 1.104. We have used the binomial theorem to expand some binomial expressions. In some questions, you may be asked to find the value of specific terms in the binomial expression, or you may be asked to find the coefficient of some specific terms in the binomial expression. We are going to learn how to solve questions of that nature. We are going to learn how to find a term in a binomial expression. We have learned that if you have a binomial expression of the form a plus x exponent n, where x is a positive whole number, then by using the binomial theorem, x expansion will be n combination 0, a exponent n, x exponent 0 plus n combination 1, a exponent n minus 1, x exponent 1 plus n combination 2, a exponent n minus 2, x exponent 2, and the order continues on and on. Now, using this, we can deduce that if you have a term in the binomial expansion, let's say if you want to find the rth term in a binomial expansion, then it's going to be n combination k, a exponent n minus k, x exponent k, where k is equal to r minus 1. Now, let me use some examples to explain this to you. So let's say if you want to find the third term. So if you want to find the third term, let's say you want to find the third term. If you want to find the third term, then it means that r is 3. And if r is 3, then it means that k will be equal to 3 minus 1, which is 2. So here the third term will be n combination k, which is now 2, then a exponent n minus k, which is now 2, then x exponent k, which is now 2. So you can see the third term here will be the same as the third term in the binomial expansion. So anytime you want to find a specific term or a particular term in the binomial expansion, we can use this formula. Let's use this to solve some questions. The question we have here is find the coefficient of x exponent 4 in the binomial expansion of 3 minus 2x exponent 6. This is a multiple choice question, and so we will solve the question, and then after that we will pick the correct option. We are going to find the coefficient of the term that contains x exponent 4 in the binomial expansion of 3 minus 2x exponent 6. We have just learned that if you have a binomial expression of the form a plus x exponent n, then a term in the binomial expansion, so let's say the rth term, will be given by the formula n combination k, a exponent n minus k, x exponent k, where k is equal to r minus 1. When we compare a plus x exponent n to 3 minus 2x exponent 6, we can see that a, which is the first term, is 3. X, which is the second term, is negative 2x. And n, which is the exponent on the binomial expression, is 6. In the binomial expression we have here, 3 is the first term and negative 2x is the second term. So it means that when we write the expansion for this particular binomial expression, x will be in ascending powers. X will be in ascending powers, which means that in the first term of the expansion, x will have an exponent of 0. In the second term of the expansion, x will have an exponent of 1. In the third term of the expansion, x will have an exponent of 2. In the fourth term, x will have an exponent of 3. And in the fifth term, x will have an exponent of 4. So the term that will have x exponent 4 is the fifth term. So here we are looking for the fifth term, which means that r is 5. We are looking for the fifth term. Now, if r is 5, then k, which is r minus 1, will be equal to 5 minus 1, which is 4. So k is 4. We can now substitute everything in the formula here so that we'll be able to get the coefficient of the term that has x exponent 4, which will be the fifth term. So the fifth term will be equal to n is 6, so 6 combination k, which is 4, times a is 3, so 3 exponent, n is 6, k is 4, so 6 minus 4, times x is negative 2x, because negative 2x is the second term here. So negative 2x exponent k, k is 4, so exponent 4. 6 combination 4 gives us 15. 6 minus 4 is 2. So we have 3 exponent 2. So 15 times 3 exponent 2. Then times negative 2x exponent 4 gives us 16x exponent 4. 15 times 3 squared, which is 9, times 16 will give us 2160. So we are going to have 2160x exponent 4. It means that in the binomial expansion of this expression, the fifth term, which is the term that has x exponent 4, is 2160x exponent 4. So the coefficient of x exponent 4 is 2160. When we look through the options, we can see that the correct option is D. Let's look at the next question. Find the fourth term in the expansion of 3x minus y exponent 6. This is a multiple choice question, and so we will solve the question and then we will pick the correct option afterwards. We have just learned that if we have a binomial expression of the form a plus x exponent n, then a term in the binomial expansion, so let's say the rth term, will be given by n combination k, a exponent n minus k, x exponent k, where k is equal to r minus 1. Here, we want to find the fourth term. So it means that r is equal to 4. And if r is equal to 4, then k, which is r minus 1, will be 4 minus 1. And this gives us 3. So k is 3. When we compare a plus x exponent n to 3x minus y exponent 6, we can see that a, which is the first term, will be 3x. Then x, which is the second term, will be negative y. Then n, which is the exponent on the binomial expression, is 6. So n is 6. Now let's substitute this into the formula. So this will give us, we are looking for the fourth term. So the fourth term will be n, which is 6, combination k, which is 3. A, which is the first term, is 3x. So 3x exponent n is 6 minus k is 3. Then times x, which is the second term, is negative y. So negative y exponent 3. Let's simplify this. This will give us 6 combination 3 is 20. 6 minus 3 will give us 3. So we are going to have 3x exponent 3 times negative y exponent 3. This will give us 20 times 27x cubed times negative y cubed. And this gives us negative 540 x cubed y cubed. So in the expansion of the expression 3x minus y exponent 6, the fourth term will be negative 540 x exponent 3 y exponent 3. When we look through the options, we can see that the correct one is A. Let's look at the next question. The fifth term in ascending powers of x in the binomial expansion of 2x minus 1 exponent 6 is, we have a multiple choice question here, and so we will solve the question, and after that we'll pick the correct option. We are looking for the fifth term in ascending powers of x in the binomial expansion of 2x minus 1 exponent 6. Here, the question tells us that x should be in ascending powers. We know that for x to be in ascending powers, then the term containing x should be the second term in the binomial expression. Here, the term containing x is 2x. It is the first term. So it means that we have to rearrange it such that 2x will be the second term. Because if 2x is the second term, then in the binomial expansion, x will be in ascending powers. We have just learned that a term in the binomial expansion will be given by n combination k, a exponent n minus k, x exponent k, where k is equal to r minus 1. Here we are looking for the fifth term, So it means that r is 5. So if r is 5, then k, which is r minus 1, will be 5 minus 1, which is 4. Because the question says that x should be in ascending powers, we will have to interchange the positions of 2x and negative 1. So 2x minus 1 exponent 6 will become negative 1 plus 2x exponent 6. Because when we have negative 1 plus 2x exponent 6, in the expansion, x will be in ascending powers. And so we are going to use negative 1 plus 2x exponent 6. When we compare negative 1 plus 2x exponent 6 to a plus x exponent n, we can see that a, which is the first term, will be negative 1. X, which is the second term, will be 2x. And n, which is the exponent on the binomial expression, is 6. So we have k as 4, a as negative 1, x as 2x, and n as 6. So we can substitute that here. We are looking for the fifth term, And so the fifth term will be equal to n, which is 6, combination k, which is 4, a is negative 1, so negative 1, exponent n is 6, minus k, which is 4, times x, which is the second term, is 2x exponent k, which is 4. 6 combination 4 gives us 15. 6 minus 4 is 2. Negative 1 exponent 2 is 1. 2x exponent 4 is 16x exponent 4. 15 times 1 times 16 gives us 240. So the fifth term in ascending powers of x in the binomial expansion of 2x minus 1 exponent 6 is 240 x exponent 4. When we look through the options, we can see that the correct one is D. Let's consider the next question. We have another multiple choice question here. So we are going to solve it, and after that we will pick the correct option. It says that we should find the numerical coefficient of b exponent 17 in the expansion of a plus b exponent 20. So we are looking for the term that has b exponent 17. We are looking for the term that has b exponent 17. Then we will find its numerical coefficient. So we are going to find the term that contains b exponent 17. Then its numerical coefficient will be the answer to this question. We have just learned that if you have a binomial expression of the form a plus x exponent n, then a term in the binomial expression, that's the, let's say the rth term, will be given by n combination k a exponent n minus k x exponent k, where k is equal to r minus 1. Here we are looking for the term that has b exponent 17. When we compare a plus x exponent n to a plus b exponent 20, we can see that a is a. So the first term here is the same thing here, a. So a is a. X, which is the second term, is b. And n, which is the exponent on the expression, is 20. So n is 20. Now we are looking for the term that contains b exponent 17. Now we know that b is x. So in the formula here, we are looking for the term that contains x exponent 17. So it means that k is 17, because we are looking for the term where the exponent on b is 17 and b here is x. So you have k to be 17. If k is 17, then it means that that term will be the 18th term, because r will be equal to k plus 1. So if k is 17, then we are looking for the 18th term. So the 18th term will be equal to n is 20, combination k is 17, a is the same as a, exponent n is 20 minus k, which is 17, times x, which is b exponent 17. Let's simplify this. 20 combination 17 is 1140. 20 minus 17 is 3, so we are going to have a exponent 3 times b exponent 17. So this gives us 1140, a exponent 3, b exponent 17. So the term that contains b exponent 17, its numerical coefficient, that is the number in the term, is 1140. When we look through the options, we can see that the correct one is B, 1140. Let's look at the next question. The coefficient of x cubed in the expansion of b plus 3x exponent 4 is 54. Find b. This is a multiple choice question, and so we will solve the question, and after that we will pick the correct option. The question says that when we expand the binomial expression b plus 3x exponent 4, the term that has x exponent 3 or x cubed, its coefficient is 54. We are going to use this information to find the value of b. So here what we will do is that we will first find the term that has x exponent 3. Then we will equate the coefficient of that term to 54. From there we will be able to find b. We have learnt that if you have a binomial expression of the form a plus x exponent n, then a term in the binomial expression, or let's say the rth term, will be given by n combination k a exponent n minus k, x exponent k, where k is equal to r minus 1. Here, if we compare a plus x exponent n to b plus 3x exponent 4, we can see that the first term a is b, the second term x is 3x, and n, which is the exponent on the binomial expression, is 4. So n is 4. In the binomial expression given to us, we can see that 3x is the second term, b is the first term, and 3x is the second term. Because 3x is the second term, the exponents or the powers of x will be in ascending order. So it means that in the first term of the expansion, x will have an exponent of 0. In the second term of the expansion, x will have an exponent of 1. In the third term, x will have an exponent of 2. And in the fourth term, x will have an exponent of 3. So the term that has x exponent 3 will be the fourth term. So here we are looking for the fourth term, which means that r is equal to 4. If r is equal to 4, then k, which is r minus 1, will be k will be equal to 4 minus 1, which is 3. So the first term a is b, the second term x is 3x, n is 4, and k is 3. Let's substitute this information into the formula. When we do that, we are going to have the fourth term will be 4 combination 3, because n is 4 and k is 3. A, which is the first term, is b. So b exponent n is 4, k is 3, so 4 minus 3. X, which is the second term, is 3x, so 3x exponent 3. 4 combination 3 is 4. 4 minus 3 is 1, so we are going to have b exponent 1, which is the same as b. Then 3x cubed will give us 27x cubed. 4 times b times 27x cubed will give us 108bx cubed. The question says that in the expansion of b plus 3x exponent 4, the coefficient of the term that has x exponent 3 is 54. When we found the term that has x exponent 3, we had 108b x exponent 3. The coefficient of x exponent 3 here is 108b. So it means that 108b is equal to 54. So we are going to equate 108b to 54. To get b, we will divide both sides by 108. So b will be equal to 54 divided by 108. And this will give us 1 divided by 2. So the value of b is 1 divided by 2. When we look through the options, we can see that the correct option is D. Let's consider the next question. Find the constant term in the expansion of x plus 1 divided by x exponent 6. This is a multiple choice question. And so we will solve the question, and after that we will pick the correct option. This question is very interesting. It's quite different from the questions that we have solved previously. We are going to find the constant term in the expansion of x plus 1 divided by x exponent 6. This means that when we expand this binomial expression, one of the terms will be a constant term. The question wants us to find that term. The constant term will be the term that does not contain a variable. Here the variable is x, so the constant term will be the term that does not contain x. Or in other words, the constant term will be the term where the exponent of x is 0. This is what I mean. Let's consider this example. Let's say we have an expression like 2x squared plus 3x plus 5. Now in this expression, 2x squared is the first term. In the first term, which is 2x squared, x has an exponent of 2. 3x is the second term. X has an exponent of 1. The last term is 5. We can see that there is no x attached to it. So it is called the constant term. We can write an x attached to it, but that x will have an exponent of 0. So 5 can also be written as 5x exponent 0. 5x exponent 0 will be the same as 5 because x exponent 0 will give us 1, and 5 times 1 will give us 5. So as I said previously, in an expression, the constant term is the term that does not contain a variable, or in other words, it is the term where the exponent on the variable is 0. So here, the constant term in the expansion of this binomial expression will be the term where the exponent of the variable is 0. And so we are going to write the expression for a term in this expansion. Then we will equate the exponent on x to 0. That will help us to get the constant term. Let's start. We have learned that if you have a binomial expression of the form a plus x exponent n, then a term in the expansion of the binomial expression will be given by n combination k, a exponent n minus k, x exponent k, where k is equal to r minus 1. When we compare a plus x exponent n to x plus 1 divided by x exponent 6, we can see that the first term a is x, the second term x is 1 on x, and n, which is the exponent of the binomial expression, is 6, so n is 6. We are looking for the constant term, so we don't know the value of k. And so we will write this expression, then we will equate the exponent on x to 0 so that we'll be able to get the value of k. With the value of k, we will be able to find the constant term. So we are going to substitute the information that we have here into the formula. When we do that, we are going to have n is 6, so 6 combination k. We don't have the value of k yet. So 6 combination k times a is the first term, and here the first term a is x. So x exponent n is 6, 6 minus k times x is the second term. Here the second term is 1 divided by x, so 1 divided by xk. Let's continue with the simplification here. This gives us 6 combination k times x exponent 6 minus k times 1 divided by x exponent k gives us x exponent negative k. We learnt this from indices. 1 divided by x exponent k gives us x exponent negative k. So from indices, we know that if we have a exponent x times a exponent y, you can write it as a exponent x plus y. Here we have x here, we have x here, they are multiplying. They have the same basis, so we can add the exponents. So when we do that, we are going to have 6 combination k times x exponent 6 minus k plus minus k will give us 6 minus k minus k. This will give us 6 combination k times x exponent 6 minus 2k. Negative k minus k gives us negative 2k. So we have 6 combination k times x exponent 6 minus 2k. As I've already explained, the constant term is the term where the exponent on the variable is 0. In this binomial expression, the variable is x. So the constant term will be the term where the exponent on x is 0. Here, the exponent on x is 6 minus 2k. So to get the constant term, we will have to equate 6 minus 2k to 0. 6 minus 2k is equal to 0. 2k will be equal to 6. To get k, we will divide both sides by 2. So k will be equal to 3. So it means that for the constant term, k is equal to 3. So to get the value of the constant term, we will have to substitute k is equal to 3 into this expression. When we do that, we are going to have 6 combination 3 times x exponent 6 minus 2 times 3. Now look at this. 2 times 3 gives us 6. So this will give us x exponent 6 minus 6. And 6 minus 6 is 0. X exponent 0 will give us 1. So for the constant term, we are going to have 6 combination 3 times 1. 6 combination 3 is 20. 20 times 1 is 20. So it means that for this particular binomial expression, when we expand it, the constant term will be 20. When we look through the options, we can see that the correct option is C. Let's consider another question. Find the constant term of the binomial expansion 2x squared minus 1 divided by x exponent 9. This is a multiple choice question, and so we will solve the question, and after that we will pick the correct option. This question is quite similar to the one we solved in the previous example. We have learned that if you have a binomial expression of the form a plus x exponent n, then a term in the binomial expansion, that is the rth term, will be given by the formula n combination k, a exponent n minus k, x exponent k, where k is equal to r minus 1. Here, if we compare 2x squared plus 1 divided by x exponent 9 to a plus x exponent n, we will see that a, which is the first term, is 2x squared. X, which is the second term, is 1 divided by x. And n, which is the exponent on the binomial expression, is n. We are looking for the constant term. Just as we saw in the previous example, the constant term will be the term where the exponent on the variable is 0. In this binomial expression, the variable is x, so the constant term will be the term where the exponent on x is 0. And so we are going to substitute the information we have here into the formula. Then we will equate the exponent on x to 0 for the value of k. When we get the value of k, we will use it to find the constant term. As we can see here, the first term is 2x squared, the second term is 1 divided by x, and the exponent n is 9. So a will be 2x squared, x will be 1 divided by x, and n will be 9. Let's substitute that here. So the constant term will be n is 9. So 9 combination k times a is 2x squared. So 2x squared exponent n minus k, and n is 9. So 9 minus k times x is 1 divided by x. So 1 divided by x exponent k. Let's simplify this. From indices, we know that if we have a times b exponent n, it can be written as a exponent n, b exponent n. So if we apply that here, then 2x squared exponent 9 minus k can be written as 2 exponent 9 minus k, then times x squared times 9 minus k. So you give the 9 minus k to 2 as an exponent, then you give the 9 minus k to x squared as an exponent. X already has an exponent of 2 here. So it's going to be 2 into brackets 9 minus k. We also know that 1 divided by x exponent k can be written as x exponent negative k. We know this from indices. If you have 1 divided by x, it can be written as x exponent negative 1. And because we have an exponent of k here, 1 divided by x exponent k will be x exponent negative 1, then the exponent of k, which is already here, and this will be x exponent negative k. Let's continue with our simplification. So this becomes 9 combination k times 2 exponent 9 minus k times, we have x exponent 2 into bracket 9 minus k times x exponent negative k. They have the same basis and they are multiplying, so we can add the exponents. From indices, we know if we have a exponent x times a exponent y, it can be written as a exponent x plus y. Here we have a base of x, a base of x. They are multiplying, and so we can add the exponents. If we apply this here, we are going to have x exponent 2 into bracket 9 minus k plus negative k. And that will give us x exponent 2 into bracket 9 minus k minus k. Let's continue. 2 times 9 gives us 18. 2 times negative k gives us negative 2k. So we are going to have 18 minus 2k minus k. And that gives us 18 minus 3k, because negative 2k minus k gives us negative 3k. So our expression is now 9 combination k times 2 exponent 9 minus k times x exponent 18 minus 3k. Remember, we said that the constant term will be the term where the exponent of x is 0. Here, the exponent of x is 18 minus 3k. So in the constant term, 18 minus 3k will be equal to 0. So here, we will equate 18 minus 3k to 0 for the value of k. 18 minus 3k is equal to 0. And so 3k will be equal to 18. We divide both sides by 3 for the value of k, and k will give us 6. This means that for the constant term, k is 6. So we will substitute that here. K is now 6. We have the value of k. And so this becomes 9 combination 6 times 2 exponent 9 minus 6 times x exponent 18 minus 3 times 6. 9 combination 6 is 84. 9 minus 6 is 3. So we have 2 exponent 3, and that gives us 8. 3 times 6 is 18. 18 minus 18 is 0. And so this becomes x exponent 0, and x exponent 0 is 1. 84 times 8 times 1 gives us 672. So it means that in the expansion of 2x squared plus 1 divided by x exponent 9, the constant term will be 672. When we look through the options, we can see that the correct one is A. So far, in all the binomial expressions that we have considered and expanded, we can see that the exponent on the binomial expression is positive. What if we have an instance where the exponent on the binomial expression is not positive? What if it is a negative number or it's a fraction? How are you going to expand a binomial expression in such case? Let's learn how to do that. Let's say that we have the binomial expression 1 plus x exponent n, where n is either positive, negative, or a fraction. If you have a binomial expression of this nature, 1 plus x exponent n, then the binomial expression can be expanded as 1, which is the first term, plus nx, which is the second term, plus n times n minus 1 divided by 2 factorial x squared, which is the third term, plus n times n minus 1 times n minus 2 divided by 3 factorial x cubed, which is the fourth term, and the order continues on and on. Now let's study this formula carefully. As you can see here, this is the expansion of a binomial expression of the form 1 plus x exponent n. So here, before we can use this formula, the first term must be 1. Before we can use this formula, the first term of the binomial expression must be 1. Now, when we look at the formula, you don't necessarily have to memorize it. There is a pattern developing, so we can use that pattern to generate the other terms. The first term of the expansion will always be 1. The second term will be nx. Now for the third term, look at it. We have n into bracket n minus 1 divided by 2 factorial, then x squared. The next term is n into bracket n minus 1, n minus 2 divided by 3 factorial x cubed. So from this, you can see that the next term will be n into bracket n minus 1, n minus 2, n minus 3, all divided by 4 factorial x exponent 4. Then the order continues on and on and on. You can use this formula to expand a binomial expression of this nature when n is either positive, when n is negative, or when n is a fraction. Here we have 2 factorial, 3 factorial, 4 factorial, and so on and so forth. You can find the value of any given factorial on your calculator. Let's learn how to do that. I have my calculator here. Let's say I want to find 3 factorial. To get 3 factorial, I'll press 3, then I'll press Shift and this button, the button on top of log. That is the factorial button. So you see the calculator gives us 3 factorial, then you press equal to. So 3 factorial gives us 6. The expansion of 3 factorial is 3 times 2 times 1. 3 times 2 times 1 gives us 6. Let's say I want to find 5 factorial. So to get 5 factorial, I'll press 5, then Shift, and then this button, that is the button on top of log, that gives us 5 factorial. Then I'll press equal to. 5 factorial gives us 120, because 5 factorial is 5 times 4 times 3 times 2 times 1, and that gives us 120. Let's try one last one. Let's say I want to find 4 factorial. So to get 4 factorial, I'll press 4, then Shift, and then this button, the button on top of log. Then I'll press equal to. 4 factorial gives us 24. 4 factorial, if you want to expand it, is 4 times 3 times 2 times 1, which is 24. So this is how to find a factorial on your calculator. Now that we know how to do this, let's use the formula that we have learned here to solve some questions. Remember that before you can use this formula, the first term in the binomial expression should always be 1. Okay. Let's consider some questions. Write down the first 3 terms in the expansion of 1 plus x exponent negative 3. You can see that here the exponent on the binomial expression is a negative number, so we can't use the normal binomial theorem that we have been using. But we have learned that if you have a binomial expression of the form 1 plus x exponent n, where n is a positive number or a negative number or a fraction, then this will be the expansion of the binomial expression. When we compare 1 plus x exponent n to 1 plus x exponent negative 3, we can see that the first term 1 is 1, the second term x is x, and the exponent n is negative 3. So we will substitute this into our formula here. Remember that we are writing only the first 3 terms. So the first term, the second term, and the third term. Then after that, we will bring the 3 dots to show that other terms also follow. So here, in the expansion, the first term will always be 1. So the first term is 1 plus n is negative 3, x is x here. So negative 3 times x, that will be the second term. Then the third term will be n is negative 3. So we have negative 3 into brackets, negative 3 minus 1 divided by 2 factorial. X is x, so x squared, then plus the 3 dots to show that other terms also follow. Let's simplify this. 1 is 1. Negative 3 times x will give us negative 3x. Negative 3 times negative 3 minus 1. Negative 3 minus 1 will give us negative 4. Negative 3 times negative 4 will give us 12. 2 factorial is 2. 12 divided by 2 will give us 6. So we have 6x squared. And so the first 3 terms of the binomial expansion of 1 plus x exponent negative 3 will be 1 minus 3x plus 6x squared. Let's consider the next question. Expand 1 minus x exponent negative half in ascending powers of x up to the third term. Hence, evaluate 100 divided by 99 exponent half. Correct to 2 decimal places. So here our question is in 2 parts. For the first part, we are going to expand 1 minus x exponent negative half in ascending powers of x up to the third term. That is, the powers of x should increase as we move from the first term to the second term to the third term. Then we would use the results to evaluate 100 divided by 99 exponent half and correct our answer to 2 decimal places. We have learnt that if you have a binomial expression of the form 1 plus x exponent half, it can be expanded as this. 1 as the first term, then the second term is nx, the third term is n into bracket n minus 1 divided by 2 factorial x squared. The third term is n into bracket n minus 1 times n minus 2 divided by 3 factorial x exponent 3 plus, and then the other terms also continue. Now by comparing, when we compare 1 minus x exponent negative half, when we compare it to 1 plus x exponent n, we can see that the first term is 1, so we have 1 here. The second term, which is x, is negative x, so we are going to substitute negative x here in place of x. Then the exponent, which is n, the exponent n is negative half. So we are going to substitute x with negative x and n with negative half. Remember, we are doing it up to the third term, so the first, second, and third. When we do that, we are going to have the first term is always 1, so 1 plus n is negative half, x is negative x. So that will be for the second term. Then for the third term, n is negative half, so negative half into brackets, another negative half minus 1 divided by 2 factorial. X is negative x, so negative x squared. The question says that we are expanding up to the third term, so we are going to end here. But you bring the addition sign and the 3 dots to show that other terms also continue from here. Let's simplify this. You have 1 plus negative half times negative x gives us half x. then negative half times negative half minus 1 divided by 2 factorial gives us 3 divided by 8. Negative x squared gives us x squared. So it means when we expand this up to the third term, we are going to have 1 plus half x plus 3 divided by 8 x squared. Let's consider the second part of the question. The second part of the question says that we should use our expansion to evaluate 100 divided by 99 exponent half and correct our answer to 2 decimal places. This is our expansion. In order for us to use our expansion to evaluate 100 divided by 99 exponent half, we will have to express 100 divided by 99 exponent half in the same form as 1 minus x divided by negative half, so that we can get the value of x. Then we will substitute that value of x into the expansion. So let's do that. By comparing, we can see that the exponent on the binomial expression is negative half, but the exponent on our number here is half. So we have to make sure that the exponent on the number is also negative half. From indices, we know that if you have a divided by b exponent n, it can be written as b divided by a exponent negative n. So we will reciprocate the fraction. The numerator becomes the denominator and the denominator becomes the numerator. Then the positive exponent changes to negative. So here 100 divided by 99 exponent half can be written as 99 divided by 100 exponent negative half. So the exponent is now negative half. 99 divided by 100 gives us 0.99. So we have 0.99 exponent negative half. Now it's beginning to look like our binomial expression here, but it's not done yet. We still have some work to do. When we compare 1 minus x exponent negative half to 0.99 exponent negative half, you can see that they both have an exponent of negative half, so we can equate the bases. So when we equate the bases, we are going to have 1 minus x is equal to 0.99. So from here we can say that x is equal to 1 minus 0.99, and that gives us 0.01. So this means that if we want to use our expression here to evaluate 100 divided by 99 exponent half, we will have to substitute x is equal to 0.01 into our expansion. So let's do that. We know that x is 0.01, so 0.99 can be written as 1 minus 0.01. And so our 100 divided by 99 exponent half, we have now been able to express it as 1 minus 0.01 exponent negative half. So we can say 1 minus 0.01 exponent negative half. Now this will give us an approximate value. The reason why it's giving us an approximate value is that there are other terms that follows this expansion. We only expanded up to the third term. So the value that we are getting here is not the actual value. It is an approximate value. So this gives us approximately 1 plus, we are substituting x equal to 0.01. So where we see x, we replace it with 0.01. So 1 plus half times 0.01 plus 3 divided by 8 times 0.01 squared. Now this will give us 1.01. So 1 plus half into bracket 0.01 plus 3 divided by 8 times 0.01 squared gives us 1.01. So this means that if we use the expansion of 1 minus x exponent negative half up to the third term to evaluate 100 divided by 99 exponent half and correct our answer to 2 decimal places, we are going to have 1.01. Let's consider the next question. Expand 1 minus x exponent 1 divided by 3 in ascending powers of x up to the third term. Hence, evaluate the cube root of 0.997 correct to 3 decimal places. Let's start with the first part of the question. So we are going to expand 1 minus x exponent 1 divided by 3 in ascending powers of x up to the third term. We know that if you have an expression of the form 1 plus x exponent n, it can be expanded as this. Now, by comparing 1 plus x exponent n to 1 minus x exponent 1 divided by 3, we can see that 1 is 1. The second term, which is x here, is negative x in the binomial expression here. And the exponent, which is n, is 1 divided by 3. So we are going to substitute this into the expansion here. Remember, we are only doing it up to the third term. That is the term containing x squared. So this will give us 1 plus 1 divided by 3 times negative x plus 1 divided by 3 times 1 divided by 3 minus 1 divided by 2 factorial, then negative x squared. When we simplify this, we are going to have 1 minus 1 divided by 3x minus 1 divided by 9x squared. We are only doing it up to the third term. Let's consider the next part of the question. The next part of the question says that we should use our expansion to evaluate the cube root of 0.997 and correct our answer to 3 decimal places. From indices, we know that the cube root of 0.997 can be written as 0.997 exponent 1 divided by 3. So here we are going to express 0.997 exponent 1 divided by 3 in the same form as 1 minus x exponent 1 divided by 3. By comparing, we can see that 1 minus x will be equal to 0.997. So 1 minus x is equal to 0.997. And so x will be equal to 1 minus 0.997. And this gives us 0.003. So it means that 0.997 can also be written as 1 minus 0.003. And so when we compare, we can see that the exponent here is 1 divided by 3. The exponent here is also 1 divided by 3. We have 1 here, we have 1 here. We have negative x here. Here we have negative 0.003. So we can see that x is 0.003. So if we want to use our expansion to evaluate the cube root of 0.997, we will have to substitute x is equal to 0.003 into our expansion here. Let's do that. When we do that, we are going to have 1 minus 0.003 exponent 1 divided by 3 is approximately 1 minus 1 divided by 3 times 0.003 minus 1 divided by 9 times 0.003 squared. And this will be equal to 0.999. So what this means is that if we use the expansion of 1 minus x exponent 1 divided by 3 to evaluate the cube root of 0.997 and correct our answer to 3 decimal places, we are going to have 0.999. Let's consider the next question. The next question says that we should write down the first 4 terms of the binomial expansion of the cube root of 1 plus x. Then we are going to use the expansion in I to evaluate the cube root of 9 and correct our answer to 3 decimal places. Write down the first 4 terms of the binomial expansion of the cube root of 1 plus x. We know that if you have a binomial expression of the form 1 plus x exponent n, this is going to be the expansion. From indices, we know that the cube root of 1 plus x is the same as 1 plus x exponent 1 divided by 3. So when we compare 1 plus x exponent n to 1 plus x exponent 1 divided by 3, we can see that 1 is 1, x is x, and the exponent n is 1 divided by 3. So here we are going to substitute n is equal to 1 divided by 3 here. We are doing it up to the first 4 terms. So the first term is 1. The second term will be 1 divided by 3 times x. The third term will be 1 divided by 3 times 1 divided by 3 minus 1 divided by 2 factorial x squared. The fourth term will be 1 divided by 3 times 1 divided by 3 minus 1 times 1 divided by 3 minus 2 divided by 3 factorial x cubed. Then you bring the addition sign and the 3 dots to show that other terms also follow. When you simplify this, we are going to have 1 plus 1 divided by 3x minus 1 divided by 9x squared plus 5 divided by 81x cubed. Then you bring the addition sign and the 3 dots. So we have been able to expand this up to the first 4 terms. The second part of the question says that we should use our expansion, which is what we have here, to evaluate the cube root of 9. And we are supposed to correct our answer to 3 decimal places. From indices, we know that the cube root of 9 can be written as 9 exponent 1 divided by 3. So as usual, we will express 9 in terms of 1 plus x. So by comparison, we can see that the first term will be 1, the second term will be 8. So as usual, we will substitute x is equal to 8 into this expansion to get the value of the cube root of 9. But when we do that, it's not going to work. And here is the reason why it's not going to work. You see, if you have the binomial expression 1 plus x exponent n and you expand it, we have learned that this is what you are going to get. Now, this expansion is valid if the absolute value of the term containing x is less than 1. From algebra, we know that the absolute value of x is x. So the absolute value of x less than 1 can be written as x is less than 1. What this means is that we can only use this expansion to evaluate a number if the value of x that we are substituting into the expansion is less than 1. Here, if we substitute 8 into the expansion, it will not work because 8 is not less than 1. So it means that we have to do something about what we have here so that we will be able to substitute a value of x that is less than 1 into this expansion. We know that 1 plus 8 can be written as 8 into bracket 1 plus 1 divided by 8. Now look at it. 8 times 1 will give us 8. 8 times 1 divided by 8 will give us 1. So we have not changed anything. Now remember, there is an exponent here, so the exponent should be here. From indices, we know that if you have a times b exponent n, it can be written as a exponent n, b exponent n. So here we can give the exponent 1 divided by 3 to 8 and give it to 1 plus 1 divided by 8. So when we do that, we are going to have 8 exponent 1 divided by 3 times 1 plus 1 divided by 8 exponent 1 divided by 3. 8 exponent 1 divided by 3 gives us 2. So this gives us 2 times 1 plus 1 divided by 8 exponent 1 divided by 3. Now we have something that we can use. Consider what is in the bracket. We have 1 plus 1 divided by 8, and the exponent is 1 divided by 3. So when we compare, we can see that we have an exponent of 1 divided by 3 here, an exponent of 1 divided by 3 here. The first term is 1 here, the first term is 1. And here, x is 1 divided by 8. which is less than 1. Remember, we said that we can only substitute x values that are less than 1 into this expansion. So we can use this expansion to evaluate 1 plus 1 divided by 8 exponent 1 divided by 3. Then after that, we will multiply our answer by 2. When we multiply our answer by 2, that is going to give us the value of the cube root of 9. We are going to use our expansion to evaluate 1 plus 1 divided by 8 exponent 1 divided by 3. When we do that, we are going to have 1 plus 1 divided by 8 exponent 1 divided by 3 will give us approximately, remember this is an approximate value because there are other terms that follow. So we are going to have an approximate value here. We will substitute x is equal to 1 divided by 8 here because by comparison 1 is 1, 1 divided by 3 is 1 divided by 3, so x is 1 divided by 8. And so this gives us 1 plus 1 divided by 3 times 1 divided by 8 minus 1 divided by 9 times 1 divided by 8 squared plus 5 divided by 81 times 1 divided by 8 cubed. Remember that we will have to multiply the result here by 2 to get the value of the cube root of 9. So if we multiply it by 2, we are going to have what we have here times 2. When you evaluate this and correct the answer to 3 decimal places, you are going to have 2.080. So what this means is that if we use our expansion here to evaluate the cube root of 9 and correct our answer to 3 decimal places, we are going to have 2.080. Let's solve another question. The question here is write down the first 4 terms of the binomial expansion of 1 minus x exponent half and use your expansion in I above to evaluate the square root of 15 and correct the answer to 3 decimal places. So here we are going to write down the expansion of 1 minus x exponent half up to the first 4 terms, and then we will use the expansion to evaluate square root of 15. Then we will correct the answer to 3 decimal places. Let's start with the first part. We are going to write down the first 4 terms of the binomial expansion of 1 minus x exponent half. We have learned that if you have a binomial expression of the form 1 plus x exponent n, this is going to be the expansion. If we compare 1 minus x exponent half to 1 plus x exponent n, we can see that 1 is 1. X here is negative x, so the x is going to be negative x, and n, which is the exponent on the binomial expression, is half, so n will be half. So to get the expansion of 1 minus x exponent half, we are going to replace x with negative x and n with half here. Remember, we are writing down the first 4 terms. So 1 minus x exponent half is going to be 1 plus n is half, so half times x is negative x, then plus half times half minus 1 divided by 2 factorial. X is negative x, so negative x squared, then plus half times half minus 1 times half minus 2 divided by 3 factorial. X is negative x, so negative x cubed. We are writing down the first 4 terms, and this is the 4th term. So you bring the addition sign and the 3 dots to show that there are other terms that follow this. Let's simplify this. This will give us 1 minus half x minus 1 divided by 8x squared minus 1 divided by 16x cubed plus then the 3 dots to show that there are other terms that follow this. So these are the first 4 terms of the expansion of 1 minus x exponent half. Let's consider the second part of the question. We are going to use the expansion we have here to evaluate square root of 15 and then we will correct our answer to 3 decimal places. We know that we will have to express the square root of 15 in this form so that we get the value of x, then we substitute the value of x here. But from the previous example, we have learned that if we are going to use our expansion to evaluate an expression, then this expansion is only valid if the absolute value of the term containing x is less than 1. Here the term containing x is negative x. The absolute value of negative x is x. So what it means is that this expansion will be valid for x values that are less than 1. So the value of x that we are going to substitute in here should be less than 1. Okay. We know that square root of 15 can be written as square root of 16 minus 1, since 16 minus 1 gives us 15. Now this is the same as 16 minus 1 exponent half. The value of x that we are going to substitute in here should be less than 1. So it means that we have to do something about this. From algebra, we know that 16 minus 1 can also be written as 16 into bracket 1 minus 1 divided by 16, because 16 times 1 gives us 16. 16 times 1 divided by 16 gives us 1. We have the exponent half here, so you have to indicate that. From indices, we know that this will be equal to 16 exponent half times 1 minus 1 divided by 16 exponent half. 16 exponent half gives us 4. And what we have in the brackets will be 1 minus 1 divided by 16. The exponent here is half. When we compare the brackets to our expression, we can see that they look similar. What we have in the bracket is 1 minus 1 divided by 16 exponent half. Our expression is 1 minus x exponent half. So by comparison, we can see we have half here, 1 here, 1 here. The negative sign here, the negative sign here, x here, and then 1 divided by 16. So by comparison, we can see that x is 1 divided by 16. So if we substitute 1 divided by 16, which is less than 1, into this expansion, we are going to get the value of 1 minus 1 divided by 16 exponent half. Then after that, we can multiply the results by 4 to get square root of 15. So let's do the substitution. We are going to substitute x is equal to 1 divided by 16 into this expansion. When we do that, we are going to have the approximate value of 1 minus 1 divided by 16 exponent half to be 1 minus half times 1 divided by 16 minus 1 divided by 8 times 1 divided by 16 squared plus 1 divided by 16 times 1 divided by 16 cube. Remember that we want 4 times 1 minus 1 divided by 16 exponent half. So the approximate value of this will be 4 times 1 minus 1 divided by 16 exponent half, which is what we have here. So 4 times the whole thing here. When you evaluate this and you correct the answer to 3 decimal places, you are going to have 3.873. So this means that if we use our expression here to evaluate square root of 15 and correct our answer to 3 decimal places, we are going to have 3.873. Let's consider the last question for the lesson. Write down the first 4 terms of the binomial expansion of 2 plus x divided by 4 exponent 10 in ascending powers of x, which means that the term containing x should be the second term, which is what is happening here. Then use your expansion in I to evaluate the value of 2.025 exponent 10, correct to the nearest whole number. Let's start with the first part of the question. It says we should write down the first 4 terms in the binomial expansion of 2 plus x divided by 4 exponent 10 in ascending powers of x. We are writing down the first 4 terms. Okay. We know that if we have the binomial expression 1 plus x exponent n, it can be expanded as this. Now look at this carefully. In this expansion, the first term of the binomial expression is 1. So if we are going to use this expansion to expand a given binomial expression, the first term in the binomial expression should be 1. In our question here, the first term is 2. So it means that we have to do something about it so that the first term will be 1. Let's do that. 2 plus x divided by 4 exponent 10 can be written as 2 into brackets 1 plus x divided by 8 exponent 10. 2 times 1 is 2. 2 times x divided by 8 is x divided by 4. So we just factorized 2 out. From indices, we know that this can be written as 2 exponent 10 times 1 plus x divided by 8 exponent 10. And 2 exponent 10 will give us 1024. So we have 1024 times 1 plus x divided by 8 exponent 10. So now we can use our binomial expansion here, this expansion, to expand 1 plus x divided by 8 exponent 10. Then after that, we will multiply the result by 1024 to get the expansion of 2 plus x divided by 4 exponent 10. So let's do that. We are going to expand 1 plus x divided by 8 exponent 10. By comparison, we can see that 1 is 1, n is 10, and x will be x divided by 8. So we are going to substitute n as 10 and x as x divided by 8 into this expansion here. Let's do that. When we do that, we are going to have 1, the first term is always 1, plus the second term is n times x, n is 10, x is x divided by 8, plus the third term will be 10 times 10 minus 1 divided by 2 factorial times x divided by 8 squared, plus the fourth term will be 10 times 10 minus 1 times 10 minus 2 divided by 3 factorial times x divided by 8 cubed. Then you bring the addition sign and the 3 dots to show that there are other terms that follow this. Now let's simplify this. When you simplify this, you're going to have 1 plus 10 times x divided by 8 gives us 5 divided by 4x. Then 10 times 10 minus 1, which is 9, divided by 2 factorial times x squared divided by 8 squared will give us 45 divided by 64x squared. Then for the fourth term, you are going to have 10 times 10 minus 1, which is 9, times 10 minus 2, which is 8, divided by 3 factorial times x cubed divided by 8 cubed will give us 15 divided by 64x cubed. Now this is the expansion of 1 plus x divided by 8 exponent 10. Remember that we are looking for the expansion of 2 plus x divided by 4 exponent 10. But we know that the expansion of 2 plus x divided by 4 exponent 10 is equal to 1024 times the expansion of 1 plus x divided by 8 exponent 10. So we are going to multiply what we have here by 1024 to get the expansion of 2 plus x divided by 4 exponent 10. You can use the 1024 to multiply each term, or you can choose to leave it like this. So there is the first part of the question. Let's consider the second part of the question. So for the second part, we are going to use this expansion to evaluate 2.025 exponent 10. We have learned that if you are going to use the expansion to evaluate a number, then the absolute value of the term containing x should be less than 1. Here, the expression that we expanded was 1 plus x divided by 8 exponent 10. The term containing x is x divided by 8. So, if we are going to use this expansion to evaluate a number, then this term should be less than 1. If this term is less than 1, then we can say that x is less than 8. The value of x that we are going to substitute into this expansion should be less than 8 because the term containing x is x divided by 8. And we are saying that the absolute value of this term, which is the absolute value of x divided by 8, which is the same as x divided by 8, should be less than 1. And from here, if we multiply the left hand side by 8 and multiply the right hand side by 8, we will have x is less than 8. So what it means is that the value of x that we are going to substitute into this should be less than 8. Okay, so we are going to express 2.025 exponent 10 in the same form as 2 exponent 10 into brackets 1 plus x divided by 8 exponent 10 for the value of x. But remember that the value of x that we are going to use should be less than 8. Okay, 2.025 exponent 10 can be written as 2 plus 0.025 exponent 10. 0.025 will give us 1 divided by 40. So this gives us 2 plus 1 divided by 40 exponent 10. We want to express this in the same form as this. To get that, we are going to factorize 2 out. When we factorize 2 out, we are going to have 2 into brackets 1 plus 1 divided by 80. So look at it. 2 times 1 gives us 2. 2 times 1 divided by 80 gives us 1 divided by 40. The exponent 10 is here. From indices, we know that this can be written as 2 exponent 10. Then into brackets 1 plus 1 divided by 80 exponent 10. Now it's beginning to look like this. We still have some work to do. We have 2 exponent 10 here, 2 exponent 10 here. The exponent 10 here, exponent 10 here, we have 1 here and 1 here. But here in the fraction, the denominator is 8. Here in the fraction, the denominator is 80. So it means that we need to do something about it. 1 divided by 80 is the same as 0.1 divided by 8. So our expression becomes 2 exponent 10 into bracket 1 plus 0.1 divided by 8 exponent 10. Now by comparison, we have 2 exponent 10 here, 2 exponent 10 here. We have 1 here, 1 here. The exponent, we have 10 here, 10 here. The denominator here is 8. The denominator here is 8. The numerator here is x. The numerator here is 0.1. So it means that x is equal to 0.1. And 0.1 is less than 8. Remember we said that the value of x that we are going to substitute into this should be less than 8. That is the condition. And here x is 0.1 and 0.1 is obviously less than 8. So we can substitute 0.1 in here and it's going to give us the value of 2.025 exponent 10. Let's do that. The approximate value of 2.025 exponent 10 will be equal to, remember this is the expansion. So 1024 times 1 plus, we are substituting x is equal to 0.1. So 5 divided by 4 times 0.1 plus 45 divided by 64 times 0.1 squared plus 15 divided by 64 times 0.1 cube. When you evaluate this, you are going to have 1159.44. Remember the question said we should correct our answer to the nearest whole number. When we correct 1159.44 to the nearest whole number, we are going to have 1159. So the value of 2.025 exponent 10 corrected to the nearest whole number is 1159. This is the end of the videos on binomial theorem. Subscribe to this channel for more videos. Bye bye.